students, welcome to my class. In today's class we will continue with the chapter complex numbers of class 11. Today we are going to learn questions in miscellaneous exercise. So the first question, evaluate I power 18 plus 1 by I the whole power 25 the whole power 3. So this is the question. We have to simplify this. So first we will take this expression, that is I power 18 plus 1 by I the whole power 25. So we will simplify the expression inside the bracket first. So how to find the power of I? We have already seen in the previous video. So how to express I power 18? I power 16 into I square. So we have to express the power as a multiple of 4. So we can write 18 as I power 16 into I square plus 1 by 1 power 25, that is 1 by I power 25. I power 25, how can we express? I power 24 into I. So 24 is a multiple of 4, so we can write like this. Okay, now we will simplify this I power 16. We can write as I power 4 the whole. I square value is minus 1 plus 1 by I power 24 we can write as I power 4 the whole power 6 into I. Now we will simplify. What is the value of I power 4? I power 4 is 1. So here you will get 1 power 4, that is 1 into minus 1. So the first term is minus 1 plus here when you simplify in the denominator I power 4 value is 1. So 1 power 6 is 1. So you will get 1 by I. Second term you will get 1 by I, but here the I imaginary value is in the denominator, so we will multiply both numerator and denominator by I. So minus 1 plus I by I square. So what is the value of I square? Minus 1. So we can write this as minus 1 minus I. So the expression inside the bracket we have simplified, and what we got is minus 1 minus I. So now we have to find the cube of this. Okay, cube of this value. Therefore we have to find I power 18 plus 1 by I the whole power 25 the whole power 3. Actually we have to find the value of this expression. So what we got inside the bracket, we have simplified minus 1 minus I the whole power 3. So here we will use the identity a plus b the whole power 3, or we can take minus 1 common from this. So minus of 1 plus I the whole power 3. Okay, so this minus 1 cube is minus 1 into, here we will expand using a plus b the whole cube identity. So 1 cube plus 3a square into b plus 3ab square plus b cube. So we have expanded this using a plus b the whole cube identity. Now we will simplify. So here we will write. Now we will simplify. So minus 1 into 1 cube is 1. Here 3 into 1 square is 1. So 3 into 1 into I is plus 3I. And here I square value is minus 1. So the third term will become minus 3. And what is the value of I cube? We have already seen I cube is minus I. So the last term will be minus I. So we will simplify this, that is 1 minus 3, that is minus 2 plus 2I. Now we will simplify the imaginary part, that is plus 3I minus I, that is 2I. Now we will multiply with the minus sign. So you will get the answer as 2 minus 2I. So the value of the given expression is 2 minus 2I. Now we will see the second question. So question number 2. for any two complex numbers z1 and z2, prove that real of z1 into z2 is equal to real of z1 into real of z2 minus imaginary of z1 into imaginary of z2. So here we have two complex numbers. So we will take the complex numbers z1 and z2 as z1 we will take as a plus ib and z2 we will denote as c plus id. So we have taken the two complex numbers z1 and z2 as a plus ib and c plus id. Now we are going to find the product z1 into z2. So we are going to find the product of these two complex number, that is a plus ib into c plus id. We will multiply, so a into c and a into minus a into id. So ac plus iad. Similarly with the ib we will multiply, so ibc plus last term I into I is I square bd. You will get I square bd, and you know that the value of I square is minus 1, so the last term will be negative minus bd. So we can rewrite this as real part together we will write. So we can write this ac and this is minus bd. So we can write ac minus bd is the real part, and from these two middle terms are imaginary part. From that we will take I common. So I into AD minus AD plus BC. So this is the product of z1 and z2. Okay, now we will take real of z1 into z2. So its meaning we have to find the real part of the product of z1 and z2. So we got the product. So this is the product. From this, what is the real part? This portion. Okay, so real of z1 into z2 is ac minus bd. Now we will see what is actually A is the real part of z1. So we can write A as real of z1, and what is C? Real part of z2. So we can write, instead of C we can write is real of z2 minus what is B? B is the imaginary part of z1. So imaginary part of z1 into D is the imaginary part of z2. So imaginary part of z2. Actually this is what we have to prove. This is what we have to prove. Now we will see the third question. Question number 3. Reduce 1 by 1 minus 4i minus 2 by 1 plus I into 3 minus 4i by 5 plus I to the standard form. That is, you have to simplify this and you have to express the answer in the form a plus ib. So this is the standard form. So we will simplify now. So 1 by 1 minus 4i minus 2 by 1 plus I into 3 minus 4i by 5 plus I. So here in the expression inside the bracket, first bracket, here we will take LCM. In the first bracket we will take LCM. So 1 minus 4i into 1 plus I is the LCM. So numerator you will have 1 plus I minus 2 into 1 minus 4i. So we will multiply. So 2 into 1 minus 4i is minus 2. Then minus 2 into minus 4i is plus 8i. Okay, so we will simplify like this. Then the second term, that is 3 minus 4i by 5 plus I. So numerator 1 minus 2, that is minus 1. I plus 8i is equal to 9i. So you will get the numerator complex number as minus 1 plus 9i, and the denominator we will find out the product. So 1 into 1, that is 1 plus I minus 4i minus 4i square into 3 minus 4i by 5 plus I. Now here again we will simplify, that is minus 1 plus 9i divided by, here when you simplify 1, here I square is minus 1. So minus 4 into minus 1 is plus 4. So 1 plus 4 is 5 minus 3i. Here I terms, I minus 3i, 4i is minus 3i. So the first expression will get us minus 1 plus 9i by 5 minus 3i, and the second one is minus 3 minus 4i by 5 plus I. Now again we will multiply. So these two numerators we will multiply, and similarly denominator we will multiply. So minus 1 into 3, that is minus 3, minus 1 into minus 4i, that is 4i, plus 9i into 3 is plus 27i, 9i into minus 4i, that is minus 36i square, divided by, here we will multiply. So 5 into 5, 25 plus 5i minus 15i minus 3i square. Now we will simplify this. So minus 3, and imaginary part we will simplify. 4i plus 27i is 31i. Here minus 36 into I square value is minus 1. So minus 36 into minus 1 is plus 36, divided by, here when you simplify, minus 3 25, here minus 10i, 5i minus 15i is minus 10i, here you will have minus 3 into minus 1, that is plus 3 you will have. Now we will simplify this, that is minus 3 plus 36 is equal to 33 plus imaginary part is 31i. So 33 plus 31i divided by, here real part is 25, here you will have plus 3, so 25 plus 3 is 28 minus 10i. So we got the answer as 33 plus 31i by 28 minus 10i. Again if you see the denominator, in the denominator we have a complex number. So how to simplify again? We have to multiply both numerator and denominator by the conjugate of the denominator. So what is the conjugate of the denominator? 28 plus 10i. So we will multiply. So 33 plus 31i into 28 plus 10i divided by 28 minus 10i into 28 plus 10i. Now we will multiply. So 33 into 28. So 33 into 28. 4, 2, 26, 6, 6. So the answer is 924. So 924 plus 33 into 10i is 330i. Again 31 into 28. 31 into 28. 8, 24, 2, 6. 8, 6, 8. 6, 8, 68i. Again 31i into 10i. That is plus 310i square. Again I square value is minus 1. So this term will become minus 310. Now here we will simplify. 28, this is of the form a minus b into a plus b. So we can write 28 square minus 10i the whole square. Now we will simplify this. So 924, this will become I square value is minus 1. So here you will have minus 310. Okay. So 924 minus 310 is 614. Now we will add these two. 868 plus 330. So 8, 9, 1. So plus 1198i divided by, here 28 square, then 84 plus here 10 square is 100, I square is minus 1. So these two minus, it will become plus. So plus 100. Now we will simplify. 614 plus 1198i by, when you add these two you will get 884. So when you take 2 common, you will get 307. 307 plus 5. 599i divided by, here 884. So we can cancel these two. So 442. So you will get the answer as 307 divided by 442 plus 599i by 442. So what we have done? We have expressed the final answer in the standard form. What is the standard form? A plus plus IB form. So we got the answer. This answer is in the form A plus IB. So this is how you have to do this. Now we will see the fourth question. Question number 4. If x minus iy is equal to root of a minus ib by c minus id, then prove that x square plus y square the whole square equal to a square plus b square divided by c square plus d square. So we have given this one, we are given, and we have to prove this condition. So we will take the given expression first. X minus iy is equal to root of a minus ib by c minus id. Here if you see the right side we have square root. To remove the square root we will square on both the sides. So first we will square on both the sides, squaring on both the sides. So in the left side you will have x minus iy the whole square equal to, right side this square root symbol will get removed. Okay, so a minus ib by c minus id. Now what we have to do, we have to take modulus on both the sides. Taking modulus on both the sides. So we are taking modulus on both the sides. So modulus of x minus iy the whole square is equal to modulus of a minus ib by c minus id. Now here if you see we have a formula, property of modulus, mod z square and mod z the whole square, both the values are same. So we can use the property of modulus, this property here. So instead of this expression we can write modulus of x minus iy the whole square is equal to, here we can take another property also we have already learned, modulus of z1 by z2 is mod z1 by mod z2. We can take modulus separately for both numerator and denominator. So we can write this as modulus of a minus ib by modulus of c minus id. Now here we are going to simplify how to find modulus value. You know that root of real part square plus imaginary part square. So here we will write what is the modulus of x minus iy. So modulus of x minus iy is equal to root of x square plus y square. So here in the place we will write root of x square plus minus y the whole square, that is y square. Again we have here square. So square is equal to, what is modulus of a minus ib? Root of a square plus b square divided by what is modulus of c minus id? Root of c square plus d square. Now if you see the square and the square root will get cancelled and you will get the answer as, left side you will get x square plus y square is equal to root of a square plus b square divided by root of c square plus d square. Now you see the answer. What answer? What is the answer? X square plus y square the whole square, and right side we don't have a square root symbol. So what we will do? Squaring on both the sides. Again squaring on both sides. So squaring on both sides. So what you will get in the left side? X square plus y square the whole square is equal to, right side the square root symbol will get cancelled and you will have a square plus b square by c square plus d square. Actually this is what we have to prove. Now we will see the fifth question. So question number 5, convert the following in polar form. So the first question is 1 plus 7i by 2 minus I the whole square. So here this question, first we have to simplify and express in standard form, that is a plus ib form. We have to change the given question in a plus ib form. Then we have to find the polar form. So first we will simplify. So 1 plus 7i by 2 minus I the whole square. So 1 plus 7i by, here we will use a minus b the whole square identity, that is 2 square minus 2 into 2, that is 4i plus I square, that is 1 plus 7I by 4 minus 4I, I square value is minus 1. So now we will simplify 1 plus 7I by 4 minus 1 is 3, 3 minus 4I. Again we have to multiply both numerator and denominator by the conjugate of the denominator. So what is the conjugate of the denominator? 3 plus 4I. So we will multiply both numerator and denominator by the conjugate, that is 3 plus 4I. So we can write 1 into 3 is 3 plus 1 into 4I, that is 4I. 7I into 3 is plus 21I. 7I into 4I, that is plus 28I square, divided by, here we will multiply using the formula A minus B into A plus B, we will simplify, that is 3 square minus 4I the whole square. So we will simplify, here 3 minus 28, I square value is minus 1. So here you will get 3 minus 28, that is minus 25, and I term, when we add I term, you will get 25I divided by 9 minus 16 into I square. I square value is minus 1. So this sign will become plus. Okay. So now we will again simplify. So what we got in the numerator, minus 25 plus 25I divided by 25. So from these two we will take 25 common. So 25 into minus 1 plus I by 25. So when you cancel this, you will get the complex number in the form A plus IB, that is minus 1 plus I. Now we have to express this complex number in polar form. So we will denote this as Z. Let Z is equal to minus 1 plus I, and the ordered pair correspond to given complex number is minus 1 comma 1. So minus 1 comma 1 lies in which quadrant? Second quadrant. This point x coordinate is negative and y is positive, then Z lies in the second quadrant. So we can write Z lies in second quadrant. So minus 1 plus I is equal to, we can write R cos theta plus I R sin theta. R cos theta is equal to minus 1, R sin theta is equal to plus 1. Now the value of R is modulus of Z, that is root of x square plus y square, that is minus 1 square plus 1 square, that is root 2. The value of R is root 2. Now we will find out cos theta from this. Cos theta equal to minus 1 by root 2 and sin theta is equal to 1 by root 2. So for which angle cos and the sine value are 1 by root 2? For 45 degrees. So we will get theta is equal to pi by 4. Now the argument. So argument, since Z lies in the second quadrant, the argument formula is pi minus theta, that is pi minus pi by 4. When you simplify this, you will get 3 pi by 4. So we will write the given complex number in the polar form, that is R value is, R is root 2. So root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. So this is the polar form of the given expression. Now we will see the next question. Second question is 1 plus 3i by 1 minus 2i. So first we will simplify this and we will express this in the form A plus IB. Then we will find out the polar form. So 1 plus 3i by 1 minus 2i. So we will multiply both numerator and denominator by the conjugate of the denominator. So what is the conjugate of the denominator? 1 plus 2i. Now we will multiply numerator. So 1 into 1, 1 plus 2i plus 3i minus 6 divided by, this is 1 square minus 2i the whole square. Now we will simplify. 1 minus 6 is minus 5, and here you will have have plus 5y divided by 1 square is 1 plus 4. How? From these two we will take 5 common. So minus 1 plus I divided by 5. So these two 5 will get cancelled and you will get the complex number as minus 1 plus I. So the same complex number only you got in the previous question. So how to represent this in the polar form we have already done. Okay, minus 1 plus I we have already done in the polar form representation we have completed. So today we have completed 5 questions in miscellaneous exercise. The remaining question we will see in my next video. If you like my channel, you can share and subscribe. Your subscription my motivation. Thank you students.